A UK man in his 70s was admitted to a hospital in Cambridge with COVID-19 pneumonia. He had first tested positive for SARS-CoV-2 a month prior. Throughout his hospitalization, the patient continued to test positive with a high viral load. This, along with his worsening illness, indicated that he was battling an ongoing infection with live replicating virus for more than 100 days. His body wasn't equipped for the task. Back in 2012, he had been diagnosed with marginal B-cell lymphoma. The blood cancer, along with the treatment he received for it, had wiped out his B and T cells, both arms of his adaptive immune response, leaving him severely immunocompromised.
The case report describing this patient's infection and treatment was published in the journal Nature. It's part of a growing number demonstrating that some infected patients with severely weakened immune systems can take months to clear COVID-19, if they ever do. And virologists worry that their prolonged infections and certain therapies can provide the time and the evolutionary pressure for variants to emerge. Each virus has an average rate of mutations that it accumulates over time. Virologists sometimes refer to this as a molecular clock. Before variants began emerging, researchers would have expected SARS-CoV-2 to accumulate about 2 mutations per month. But if you look at the B.1.1.7 or Alpha variant first detected in the UK, it was ticking to a different clock.
For B.1.1.7, there were 23 mutations that differentiated it from the closest virus. So that's a lot of mutations to kind of come out of nowhere, and in a country that is very heavily sampled,
That's Dr. Ravindra Gupta, one of the physicians who cared for the patient described earlier and a co-author of the case study. At the time B.1.1.7 was detected, the UK already had a robust virus surveillance system. If B.1.1.7 was accumulating mutations as it spread from person to person, then this surveillance system should have detected it at different points in its lineage. So how is it possible that it didn't?
So Dr. Gupta told me that he believes it's evolution within a single host. And it's being hidden from our surveillance because it's happening in one patient over the course of 3 or 4 months, and then it's spreading to different people.
In a patient with a healthy immune system, the viral population would remain more or less uniform during the course of infection with SARS-CoV-2. But that's not what researchers have seen in some severely immunosuppressed patients. Let's take a look at the patient described in Nature. The physicians caring for him obtained whole genome sequencing at 23 time points over the course of his 101-day illness, starting with his first positive swab. During the initial few weeks, the viral populations were uniform.
There was very little change in the virus, actually. And the problem arose because he was getting sicker and breathless and coughing, and we had to find some treatment.
The patient received 2 courses of remdesivir, which resulted in little change in the overall structure of the viral population. Then, the patient also received 2 bags of convalescent plasma.
And unfortunately, it didn't really help to clear the infection. But what happened, as we found in the sequencing later, was that the virus started undergoing really big changes, and they seemed to kind of move up and down with the kinetics or the levels of the antibodies in the blood.
When the plasma was given, a predominant virus emerged that was resistant to the antibodies in it. Then, after a few weeks, as the plasma sort of washed out of the patient's body, different variants emerged that became predominant. Then, when another round of plasma was given, that resistant variant came back and dominated through the end of the patient's life.
While it's wise to be cautious and not extrapolate too much from one case study, it demonstrates how SARS-CoV-2 can evolve rapidly within one host when faced with selective pressure. In this case, suboptimal immune response and therapy. There's no evidence that this particular patient transmitted SARS-CoV-2 to anyone else, especially as he spent the majority of his illness isolated in the hospital. But some virologists believe that variants of concern arose when similarly chronically infected patients transmitted the virus. It is nearly impossible to prove this, so despite it being a leading hypothesis, there is not a consensus that this is what actually happened. However, there is agreement that more attention needs to be paid to the potential increased risks for immunosuppressed patients and their communities. This is especially true as research suggests that COVID-19 vaccines may not generate a robust response in some severely immunosuppressed individuals. So they may continue to be vulnerable despite being vaccinated. This is why the FDA authorized a booster dose of mRNA vaccines in August 2021 for certain immunosuppressed individuals, which may increase their protection. They are the very first group to receive a booster authorization. It's also very important to vaccinate the people around immunosuppressed individuals to create a kind of bubble. If they do become infected, one of the biggest questions is how long such patients should remain isolated. Isolating potentially contagious patients is a sound public health tactic, but it can negatively affect the individual's emotional well-being.
So while we may look at these patients as potential reservoirs of contagious virus, they're patients, they're people. And so while they need to be isolated, that takes a toll on them. And the physicians I spoke to are concerned with their well-being and want to know when they can let them go home.
The CDC says that physicians can consider using a test-based strategy to decide when to stop isolating immunosuppressed individuals. But people may test positive even after they're no longer contagious. On the ground, the protocols differ from one health facility to another. Physicians are looking at multiple factors.
They're looking at, are they still symptomatic? Are they getting worse? Obviously, are they still testing positive? Do they have a high viral load? All of those factors play into whether or not they can be released from isolation.
In addition to isolation protocols, other questions remain. There are not enough data to establish which patients are most at risk for prolonged infection, for instance. Case studies have described diverse presentations, including transplant recipients, patients with blood cancers, and a patient with untreated HIV. Some case studies have also implicated treatments such as CAR T-cell therapy and rituximab. And more data are needed on how therapies should be deployed in COVID-19 patients with any of these diverse risk factors. For millions of immunosuppressed patients and their physicians, there remains a lot of uncertainty.
So the big question is, how can we treat them to save their lives, to consider their well-being, and to also protect the community from variants of concern?
If you would like to see more content like this, please subscribe to our channel. We will continue addressing important developments regarding COVID-19 and other topics in medicine and health in upcoming videos.